Everyone, take a look at this iPad. Which model of iPad is it? The model number is on the lower back, A2228. First, let's try plugging in the charger to see what happens. After plugging in the charger, there's a charging current, but the current is extremely small. The screen doesn't show anything at all, which means it really isn't turning on. According to what the fan viewer described, the iPad got hot while he was gaming, causing it to fail to power on. So, what's the cause? Why would this happen? We heat the iPad, then lift the screen a bit, sliding around the edges of the screen. All iPads are opened from the screen first, and the screen is glued to the housing. Be careful up here, there's a flex cable at the top. We need to protect the Face ID components and not flip the screen too far. After removing this flex cable, we can then lift the screen. If you like this video, please send me some gifts. Opening the screen, we observe the inside of the housing, especially the backside of the screen. Almost all iPads look like this once you open them. You might think it's a refurbished unit. The first step is still to disconnect the battery from the logic board. Then disconnect the 4 display and touch flex cables. Because the iPad screen is pretty big, its display and touch connections are split into 2 sets. The battery is also in 2 separate pieces. With the logic board in the middle and 4 stereo speakers at the top and bottom, there's a Type-C port. Charging components, the front camera, and the Face ID unit. Over here are the rear camera and the power button. We heat the sticker on top of the logic board, then peel off this protective sticker. If you think this video is helpful, please send me some gifts. After peeling off the sticker, we can see the logic board inside. You can see that this iPad has 2 solder points for its storage drive. This is the CPU, and next to it is the power supply, charging, and audio section. Because it won't power on, we use a multimeter to compare resistance values. The positive line's resistance value is normal. We attach a power supply meter to the positive and negative terminals, press the power button, and discover a large current draw as soon as we press it. Moving to the microscope, we check for any abnormalities or suspicious areas. If you like my video, please send me some gifts. After close inspection, we didn't find anything unusual. Next, we measure around the power supply region, because the power section on this iPad is also prone to issues. After measuring, there doesn't appear to be anything abnormal. We apply rosin to all areas on the logic board that could be problematic. Then press the power button to see which part might be shorted, causing the large current draw. After multiple attempts, guess what? We press the power button again, and it's successfully powered on. Strange. What's going on here? I'm sure many of you have the same question. Initially, it was large current with no boot when pressing the power button, but after pressing it a few times with the power supply meter, it turned on. We cleaned the logic board, applied double-sided tape, then reattached the sticker. Next, I want to explain something. Please pay attention to the following. We clean off the leftover adhesive around the casing. Some people watch quietly as I fix the iPad, but they secretly like, comment, share, repost, and follow. Such people are really adorable. Then we place the screen on a heating station and remove the leftover adhesive around the screen. Thank you for your TikTok gifts. Let me tell you, an iPad is different from a phone. It's not waterproof at all, so when using an iPad, be careful, avoid getting water inside. After cleaning the old adhesive on the back of the screen, we apply the original double-sided tape. Now, why did pressing the power button a few times with the power supply meter change the situation from large current / no power on to powering on successfully? Well, initially, a capacitor at the second or third terminal was likely shorted. Pressing the power button caused a large current and no boot. A logic board that detects large current has self-protection. If we use a non-power supply source, like a normal battery, it remains in protection mode and won't power on. Even if it did turn on, it would draw large current. But since we used the power supply meter, it delivered power directly to the logic board, and after repeated attempts at powering on, that shorted capacitor burned out or broke down, so it no longer shorted to ground. This is what old repair techs refer to as the shock method, and there's no need to locate the faulty capacitor anymore. Of course, not all shorted capacitors can be fixed by this trick. Sometimes you just get lucky. After reassembling, we plug in the charger, and the iPad boots up perfectly. The fan was using a split screen mode. How do we switch it back to full screen? Tap the 3 dots to switch to full screen. Let's check about this iPad. It's a 128GB iPad Pro 11-inch, 2nd generation, and it's a U.S model. We test all the functions: sound, camera, Wi-Fi, flash, etc. Some people watch quietly, but they secretly like, comment, share, repost, and follow. Such people are so wonderful. After testing, all functions are normal. Many thanks to the fan for their support. Remember to send some TikTok gifts to Big Brother. Thank you so much. Bye-bye.